Hello viewers, welcome to Engineering Study Materials. In this video, we will discuss about the tool nomenclature. So let's get into this video. If you like this video, put a thumbs up and subscribe this channel for more videos, and also like and share this video to your friends to gain knowledge. Leave your valuable comment and thank you for watching. Tool nomenclature. Naming the various parts and angles of the cutting tools is called as nomenclature of the cutting tool. Single point cutting tool. The important parts of the single point cutting tools are shank, flank, cutting edge, face, base and nose. Shank, it is the body of the tool. This is the diagram showing the single point cutting tool. Cutting part: minor cutting edge, minor flank, major cutting edge, base, tool axis, and end cutting angle, face, shank. These are all the parts of the single point cutting tool. Face, it is the surface over which the chip slides. Flank, it is the surface of the tool facing the workpiece. There are two flanks, namely major and minor flank. Flank is the surface below the cutting edge. Base, it is the bottom surface of the shank. Cutting edge, it is the junction of the face and the flanks. There are two cutting edges, major and minor cutting edges. Nose, it is the junction of the major and minor cutting edges. Angles: top rake angle or back rake angle. Nominal rake angle is the angle made by the face of the tool and the plane parallel to the base of the cutting tool. If the rake angle is measured in the direction of the tool shank, it is called back rake angle, and if it is measured in a direction right angles to it, then it is called side rake angle. The purpose of rake angle is to allow the chips to flow plastically over the tool face so that smoother action will take place. Rake angle is the only angle on which the strength of the tool depends. The force on the tool is reduced by increasing the rake angle, but tool is weakened. In short, rake angle increases tool life, it reduces cutting forces as well as the power required, it allows chips to follow in a convenient direction, it gives sharpness to the cutting edges, increases surface finish. Positive rake angles are used to machine low strength materials and non-ferrous materials. Cutting tools with negative rake angles are stronger and are used to cut high strength alloys. Ceramic tools and hot work die steels and cemented carbides are provided with negative rake angle. Use of excessive negative rake angle leads to increase in cutting forces, so that increasing power consumption, chances for vibrations present. Side rake angle. If the rake angle is measured in a direction perpendicular to the tool shank, it is called the side rake angle. It also guides the direction of the chip away from the job. The amount that a chip is bent depends upon this angle. Side rake angle increases the power required to bend the chip is decreased and surface finish increases. Clearance angle or relief angle. When the tool is in horizontal position, the normal clearance angle is measured from the plane perpendicular to its base. End relief angle. This angle prevents the cutting tool from rubbing against the job. Side relief angle. It permits the tool to be fed sideways into the job so that it can cut without cutting. If the relief angles are very large, cutting edges of the tool will break off due to insufficient support. If the angles are very small, the tool will rub on the job. Optimal value of the end relief angle varies from 6 to 10. Cutting edge angle. End cutting edge angle between face and a plane perpendicular side of shank. It's the angle the major cutting edge angle makes with the width of the tool. Side cutting edge angles. It's the angle the side cutting edge makes with the longitudinal axis of the tool to avoid built up edge. Lip angle or cutting angle. It's the angle between face and end surface of the tool. It's usually between 60 to 80 degrees. Nose radius. Nose radius is provided to increase finish and strength of the cutting tip of the tool. Side and end cutting edges can be joined to form a point, but it leads to high heat concentration at the sharp point. Instead, joining them by an arc is common practice. Provision of nose radius improves tool life, surface finish, and decrease in cutting force. Smaller radii will produce smooth finish and are used to on thin cross section. Large radii strengthen the tool and are used on cast iron.